Welcome with Mrs. Struble. Today we're going to be talking about how to solve two-step inequalities. So the way we're going to do this is our objective is to use the properties of inequality to help solve two-step inequality statements. Before you have viewed this video, you should have already viewed how to solve one-step inequality statements and gotten a understanding of the properties of inequality themselves. Okay, so when we are solving a two-step inequality, there may be an added first step, which would be simplifying each side of the inequality. So in other words, we have to make sure this is ready to solve by combining like terms if we need to. Then we can undo subtraction or addition that was done to the variable. After we undo any subtraction or addition that was done, we can undo any multiplication or division. I like to think of it this way. We have a statement that is missing a value, okay? If we knew that value, we would follow the orders of operations in order to evaluate that expression. Since we do not know the value of one of the numbers, then we need to look at this as working the problem backwards. So we're going to have to do PEMDAS backwards. That is how we come up with the steps. So we're first going to undo any addition or subtraction, then we'll undo any multiplication or division that is happening to that missing number. That'll tell us what that number is, and we'll be able to use our solution in order to check our answer and make sure the inequality statement still makes sense. Okay, so here we go. Our first example, 7x minus 2x minus 4 is greater than or equal to 11. This is not set up to where we can simply just solve it yet. We first have to combine the like terms. So step one is to combine those like terms. And we see that there are two terms that have a variable x in them. We need to combine them. Again, this 7x simply means that there are 7 x's. Okay? Remember multiplication, 7 groups of x, whatever x is, there's 7 groups of them. Then we are going to take away 2 of those. Or you can think of it this way, we have 2 negative x's, or the opposite of x. Okay? So we have 2 opposite x's and 7 regular x's. To combine like terms, we look and see for 0 pairs, well, x minus x, that's going to be 0, so what's all left? We have 5x. Okay? Once we've combined like terms, we can recopy our inequality statement down, and we are left with 5x minus 4 is greater than or equal to 11. Okay? Then we can move on to the step 2. Step 2, as you recall, was undoing addition or subtraction. Here we see the x is being multiplied by 5, but it's also being subtracted by 4. So we have to undo that subtraction. Instead of subtracting, we need to add. And what do we need to add? We need to add 4. Because we need to keep this balance in the inequality statement, we're going to add 4 to both sides of the inequality. These 4's cancel out, and what are we left with? Well, the 5x falls down because we didn't touch it. We didn't do anything with it. And then 11 plus 4 is 15. Step 3. We have to undo the multiplication by dividing, okay? X is being multiplied by 5, so we need to divide it by 5. And what we do to one side, we need to do to the other. These 5's end up canceling out, and we are left with X is greater than or equal to 15 divided by 5 is 3. Now we have an answer. We have to make sure it makes sense in our problem. Okay, so when we see an X, we're going to substitute 3 and see if it makes sense. 7 times 3 minus 2 times 3 needs to be, I'll just go right like that real quick. Minus 4 needs to be greater than or equal to 11. Okay, so solving this expression where X is present, 7 times 3 is 21, minus 2 times 6 is 6, minus 4. Well, 21 minus 6, that's 15, minus 4, that is 11. Is 11 greater than or equal to 11? Sure enough, it is. Okay, it is in fact equal to. Okay, which means 3 is a possible answer for X. In fact, it is the smallest possible answer for X. So this inequality statement holds true. Let's do another one. In this example, we have 13 greater than or equal to b divided by negative 3 plus 4. As we can see, step one, combining like terms or making sure they're all the expressions on each side of the inequality statement are simplified. That's already done for us. Okay. Each of these statements are in fact expressions are in fact simplified. So we can move on to the next step, which is undoing any addition or subtraction that is being done to the variable. B is our variable right here. It is being divided by negative 3, but it's also being added by 4. To undo the addition, we need to subtract the 4 back out. Okay, and what we do to one side, we'll do to the other side of this inequality statement. The 4's end up canceling. We didn't touch the being divided by negative 3, and we get a 9 on the other side here. Okay. Step 3, we need to undo our multiplication or division going on. If we take a look over here, b is being divided by negative 3, so we need to undo the division by multiplying by negative 3. Okay. We're going to multiply this side by negative 3, and we're going to multiply the left side by negative 3. In order to do this properly, we need to know our properties of inequality. Okay. The multiplication and property of inequality says, when I multiply by a negative to both sides of an inequality statement, the inequality sign needs to change or be flipped. Okay, so it was greater than, it needs to be less than now. And then we copy down what's left like we would normally. So what is left? The 3's cancel. We're left with b on this side. And then negative 3 times 9. That's going to leave us with negative 27. And this is the only way to ensure that the statement will hold true. Double checking our work. That's step 4. So let's check it. The only way to properly check an inequality is to make sure we have entered a value that is true to this statement. Okay, so what does this statement say? Our answer says that negative 27 is less than b, which means b needs to be a value that is greater than negative 27. It cannot be equal to it. So when we substitute in our solution in order to check this problem, oops, that must have got erased. We need to make sure that we substitute a value that is in fact greater than 27. Okay, so thinking of a number greater than negative 27, I automatically think of 0. So let's set b equal to 0. You got another number, go ahead and use your number. I like to keep it easy, so if I can do 0, I'm going to do 0. So 0 is in fact greater than negative 27. So coming up to this statement, if I put 0 in for b, I should be able to I should get a number, a value, that is in fact less than 13, because 13 has to be greater than this right side of the inequality. Okay, so everywhere I see a b, I'm going to put a 0 here, and b can be 0 because it's not in the denominator, so that works out great for us. Right, 0 divided by negative 3. Think about it once, think about it twice. It is, in fact, 0. Okay, you'd be surprised how many say negative 3. No, 0 plus 4. You gotta think about it for a little bit. You end up with 0 divided by 3. Okay, so think about it for a little bit. Do some backtracking on your brain. All right, so I get an answer of 4. Now, is this true? Well, I can come back up here and say if I'm correct, then I can put a 4 in for all of this. I can have all of this equal 4, and my inequality statement will be true. 13 is greater than 4. That is true. Check. My inequality statement is true. B is in fact greater than negative 27, or you could say it negative 27 is less than B. Okay. You might want to consider when you have the variable on the right hand side like I do in this example, you might want to consider flipping that variable to the left hand side, especially if you are asked to graph this. Because when we graph, we are graphing B. We're not graphing negative 27 and all of its possibilities. We are graphing all of the possible answers for B. So the way this would look in a graph, we have negative 27 somewhere along here. Let's put them here. Okay. B, we need to represent B as all of the values greater than negative 27, which is all of the values to the right. Okay. Some of us have been taught a trick to look at this inequality and think that it goes left, when in fact, that's only if the variable is on the left-hand side. Okay. Notice that it cannot be equal to, so we need to leave an open circle representing everything as close as you possibly can to negative 27, but not touching negative 27 itself. Okay. So again, another way to write this is B is greater than negative 27. Both statements are true and congruent to each other. Why don't you give it a try? I'm going to, oops, okay. Pause the video, solve these two inequalities, and try and graph them also. I'll be back in a sec. Now that you've tried them, let's see how you did. Number 1, the correct response is y is greater than 2. The correct graph has an open circle at 2 and is heading to the right. So any values greater than 2. Number 2, the correct response is D is less than or equal to negative 5. You could have kept the D on the right-hand side and had negative 5 is in fact greater than or equal to D. The graph at negative 5, we have a closed circle now, representing that it can be equal to negative 5, and any value to the left-hand side of that negative 5 is correct. One final one. Get some division going in there. Try it. Pause the video. Now that you've tried the final try it example here, let's go ahead and see if you got it correct. The correct response is W is less than -4. The graph for this at -4 needs to be an open circle. That's not open. Needs to be an open circle. That's exactly what I said, but not what I drew. It's kind of funny. And heading once again to the left. Thank you for joining me as we use the properties of inequality to help us solve two-step inequalities.